Good morning. Today, my name is Roman Gogan, and today I'm going to be discussing about ECM. ECM is an electrochemical machining process. It is a non-traditional or non-conventional machining process. So ECM is the reverse of electroplating process, which removes material instead of depositing it on an electrode. So therefore, we are going to get into the mechanism of ECM. In ECM, a high electric current is being passed through the electrodes, that is the cathode and the anode, that is the tool is the cathode and the workpiece is the anode, through conductive fluid that is called an electrolyte. So with that, the electrolyte is able to carry the electric current through these electrodes, and material is being removed from the electrode. So the cavity that is on the tool is being able to replicated on the workpiece. So therefore, there is one of the characteristics of ECM is that it is a non-contact process. The tool and the workpiece, they don't have to come together or in contact, so that the process is being made. Unlike in the traditional machining processes, whereby the tool and the workpiece they come together. So you'll find that in ECM no contact is required. ECM makes use of an electrolyte and a high electric current to ionize and remove metal atoms, yielding to a buffer-free surface. So unlike in the traditional machining processes, in ECM the surface after machining is very smooth and there are no bars. So with that, those are some of the characteristics, and therefore, because it is a non-contact, therefore it doesn't matter how hard material is or the workpiece is. So because there is no that contact, there is no shear stresses that will be incurred between the tool and the workpiece, and therefore everything goes smoothly. So with that, I am going to get into the metal removal rate of ECM. So you will find that in ECM, the metal removal rate obtained in this process is considerably less than that required in a metal removal process in the traditional or the conventional machining processes. In this, very less metal removal rate is incurred or required. So in ECM, at the anode, the metal dissolves electrochemically. Rate of dissolution depends on, so the removal rate of this material from the anode or from the electrode, it will depend on the ionic charge, the atomic weight, the electric current, and the time of current passage. So the longer it takes for this electric current to be passed through the electrolyte, so the accuracy of ECM, it depends on the gap, the distance between the tool and the workpiece. If the gap is smaller, the more accurate it's going to be. The accuracy of machined parts, depend on the current density. We have the current density, which is affected by material equivalent, the gap voltage, the feed rate, gap phenomena, including the passivation. So electrolyte properties also affect. So when you're talking about electrolyte properties, we're talking about the pH, we're talking about the temperature, we're talking about the concentration, the pressure, the type of velocity. So with that, I'm going to stop there, and I'm going to welcome you to my next video. Thank you for watching, and